Hello all. Today let us see the topic properties of matter. In properties of matter we have two different terms which has to be remembered. Interatomic forces. What is meant by interatomic forces? When the force between two atoms due to electrostatic interaction between the charges of the atom. If it is due to between two atoms and due to electrostatic interaction between the charges of atoms. When it comes to intermolecular force, it is the force between two atoms due to electrostatic interaction between the charges of molecules. If it is atomic forces, it's between the charges of atom. If it is molecular forces, it's between the charges of molecules. Intermolecular force is also known as van der Waals forces. Weak in interatomic forces. These van der Waals forces are weak in interatomic forces. In nature, they are electromagnetic. Okay. Next, cohesive forces and adhesive forces. We know cohesive force is the force of attraction between the molecules of same substance, whereas adhesive force is the force of attraction between the molecules of different substances. Here, force is less in liquids, least in gases. Surface energy. These are different terms. First term is interatomic forces, intermolecular forces. Then what are differences between cohesive and adhesive forces? Now when it comes to surface energy. What do you mean by surface energy? Surface energy is defined as the potential energy of a surface molecule per unit area of surface. This is very important. Units are frequently asked in the exams. Joule per meter square. Unit of surface energy is joule per meter square. Okay. And next term is capillarity. We can define capillarity as the rise or fall of a liquid. This is capillary rise and this is capillary fall. Next term is pressure. We know pressure is load acted per unit area. Load by area. Units of pressure. Load newtons. Area meter square. Newton per meter square. Newton per meter square is also called as Pascal in SI system. In CGS system it is Dyne per centimeter square. Pascal's law can be defined as the increase in pressure at one point of enclosed liquid equilibrium of rest is transmitted equally, which means if we apply the pressure here, it is equally transmitted among here and it allows the object which is placed here to rise. Based on this principle, hydraulic lift, hydraulic press, hydraulic brakes are using in our current scenario. Okay. What is Bernoulli's theorem? Bernoulli's theorem can be defined as a total energy. Total energy which includes potential energy, pressure energy and kinetic energy per unit volume or mass of an incompressible and non-viscous fluid in a steady flow through a pipe remains constant throughout the flow. In this we have to remember that the Bernoulli principle based on the liquid which is incompressible and non-viscous fluid. Okay, what are the applications of Bernoulli's theorem? These are very important. Attraction between two closely parallel moving boats, working of an aeroplane, action of atoms or blowing off roofs by windstorms, Magnus effect, Venturi meter. These all are works on the principle of Bernoulli's theorem. What do you mean by viscosity? Fluid which opposes the relative motion between the body which are present in the different layers. Okay, here these are the points very important. If pressure increases, viscosity increases. If pressure decreases, viscosity increases. If temperature increases, pressure decreases. If temperature decreases, pressure increases. What do you understand by this? Pressure is inversely proportional to temperature. The next term here is surface tension. Surface tension can be defined as a property of a fluid due to which its free surface tries to have minimum surface area. We will consider at where the minimum surface area of the body exists. A small liquid drop has spherical shape due to surface tension. Surface tension always depends on the nature of the liquid. Surface tension is independent of area of surface, length of the line considered. These type of points are very important in case of competitive exams because these are direct to ask. Surface tension depends on nature of the fluid, whereas surface tension is independent on area of surface or length of line considered. Surface tension is a scalar quantity. Its units are Newton by meter or dyne by centimeter. What is this dimensional formula? What are the factors affecting the surface tension? If temperature increases, surface tension decreases. High soluble. If it is highly soluble in the water, then surface tension increases. When it is less soluble, then surface tension decreases. Next term is elasticity. Elasticity is ability of a material to deform without breaking. Okay. W is equal to half kx square. Here k is a spring constant. When a coil spring is compressed, the work done by the spring will be happen. Then the elastic potential will always increases. It is a bit. Here k is a spring constant, x is extension. Value is 1, then it is perfect elastic collision. If E is equal to 0, then it is perfect inelastic collision. If 0 less than E less than 1, then it is partially elastic collision. Next topic is surface tension and capillarity. We already saw viscosity. What is viscosity? Friction in liquids is called as viscosity. When it comes to surface tension, the example for the surface tension is falling drop of the water is spherical. The droplet of the water molecule is always spherical because of the property which is surface tension. And due to capillarity, when it comes to capillarity, due to capillarity action, blotting paper absorbs ink and kerosene oil rises up in the wick of the lantern in flow of liquids. A tank partially filled with a liquid is subjected to a uniform horizontal acceleration. Then the surface of the liquid falls in the direction of the motion and rises towards the back of the tank. What is ideal fluid? Ideal fluid does not exist in nature. It is always frictionless, incompressible, non-viscous, no surface tension, infinite bulk modulus. Ideal fluid, these are the features of ideal fluid. Bernoulli principle is based on the conservation of energy. We already saw it. Pressure always depends on density of the fluid, gravitational acceleration and depth of the fluid. Okay, if iron nail is dropped into the water, it submerges, whereas cork is dropped into the water, it floats, which means the density of iron nail is more than the density of cork. So that as the density is more, it is being submerged in the water. Okay. Buoyancy and Archimedes principle. What is the buoyancy? Upward force of an object when it is partially or completely immersed in a liquid. The buoyancy always acts upwards. Okay, what is center of buoyancy? Center of buoyancy always coincides with the centroid of the volume of the fluid displaced. Buoyancy depends on density of the fluid, volume of the object immersed. Who introduced buoyancy? Buoyancy is introduced by Archimedes only. Okay, designing of aeroplane wings is done by using Archimedes principle, which is buoyancy. These are the some of the points which relates Archimedes principle. Object floats on water because of Archimedes principle. Upward force experienced by a body. For example, if there is a bucket or a beaker of water and we placed a solid substance, solid body, here the amount of force experienced by this body in upward direction is equal to the fluid displaced by that body. Okay, upward force is buoyancy. The speed increases of ships is based on the theory of Archimedes. The building and movement of ships is based on opposite direction. If you fill water in a glass and ice cube, what happens when the ice melts? This is very important question. We generally think that water level will increase, but if you fill a water in a glass and an ice cube, what happens when the ice cube melts? There will be no change in water level. When the object sinks, the upthrust of the fluid on the object less than the weight of the object. Upthrust force which acts perpendicular to the plane. Hydrometer, submarine, lactometer, these are all the applications of Archimedes principle. We already studied about pressure. Pressure means force per unit area. P is equal to rho GH. These are the units. And when it comes to density, density is kg per meter cube. Density of water is maximum at 4 degrees centigrade. This is important. Density of water is maximum at 4 degrees centigrade. Relative density of silver is equal to density of silver by density of water. We already saw this. Which has more density will submerge and which has lighter density will float. When it comes to kinetic theory, in kinetic theory always gas has more kinetic theory. Solids has strong molecular attraction, force of attraction. Absolute zero temperature is achieved only when the kinetic energy of the molecules is zero. These are straightforward bits. When solid is melting, the temperature remains same. If water vapor in the atmosphere increases, then the evaporation decreases because humidity in the atmosphere increases. So, rate of change of evaporation will decrease. So, this is the basic overview of this chapter, properties of matter. Please do like, share and subscribe to our channel. Thank you.